Now, there are certain examples based on the progressive waves. That is, there are certain numericals. We have to apply the concept of the progressive waves. Normally, the concept to be applied is V is equal to n lambda, T is equal to 1 over n, omega is equal to 2 pi by T, or K is equal to 2 pi over lambda. So there is a progressive wave and the frequency 500 hertz is given, traveling with a velocity of 360 meters per second. How far apart are the 2 points 60 degree out of phase? So velocity of wave is given and frequency is 500. This is also given. According to formula, V is equal to n lambda. The wavelength is lambda is V by n. We computed the value of V and n and our result comes 0.72 meters. Now let delta x be the maximum distance between 2 points. Then the phase difference between them will be given as that is 2 pi by lambda, or phase difference is 2 pi x over lambda. So again we will compute the values and we will find, because it is written 60 degrees, so that will be pi by 3. So path difference will be 2 pi x over lambda. So this will be taken as lambda over 2 pi into delta phi. So by calculation, it becomes 0.12 meters. Now our next question is, the equation of a simple harmonic progressive wave is y is equal to this one given. Y is the displacement, 8 is the amplitude, and 12.56 t, that is the phase given, and the other number is given as 0.628. So let us check up now. The equation of wave is this much, and that is 8 sine 0.628x minus 12.56 t. That is the equation. So we will modify this equation and we can write it as y is equal to a sine 2 pi multiplied point, that is 0.1 into x and 2t. Now compare it with the standard equation. The standard equation is y is equal to a sine 2 pi into x over lambda minus t over t, and negative sign in this equation is indicating that wave is propagating in the positive direction of x-axis. That is, the wave is coming from the negative side and coming towards the positive side. Now amplitude is given according to the equation, t is given. We are basically comparing and we get these values. And finally we find frequency is 2 hertz by comparing, and wavelength is 1 over 0.1, that is 10 centimeters. So wave speed is n lambda, put the values and we get the result 20 centimeters per second. If distance between the 2 points is delta x, the phase difference will be 2 pi x over lambda, or 2 pi lambda x by lambda. So this is what the equation given. The values of lambda, delta x, delta phi, these all values are given. So we compute the values and get 72 degrees. Now in the another example, the point to note is that 54 waves are given. When we use the term one wave is equivalent to one wavelength. So 54 waves means 54 wavelengths. That is 54 into lambda. So our question is, an observer standing at the sea coast observing 54 waves. 54 waves means 54 multiplied by lambda, reaching the coast per minute. That is in 60 seconds. So for 1 second we will calculate. If the wavelength of the wave is 10 meters, find the velocity and what type of waves did he observe, explain. So he is observing the wave on the surface of water, so obviously there will be the transverse vibrations. Now the formula is V is equal to n lambda. So we have calculated the number, that is 54 by 60 multiplied 10, and that comes to 9 meters per second. The wave observed are transverse because on the water surface, transverse waves are formed. This I have just now explained. Now our next question is, a transverse harmonic wave on a string is determined by y, and the coordinates are xt, that is equal to 3 sine 36t plus 0.01818x plus p by 4. where x and y are in centimeters, t in seconds, the positive direction of x-axis from left to right. Now, is this a traveling or a stationary wave? If it is traveling, what are the speed and direction of the propagating wave? What are the amplitude and frequency? Also, we would find the initial phase and the distance between the two successive crests of the wave, that is called wavelength. Now, what are the given function? First is equation is given. That is why xt is equal to 3 sine 36t plus 0.018x plus p by 4. So y xt, we will write a general equation, a sine 2 pi by t into t minus 2 pi x over lambda plus 5. Now comparing equation number 1, and then we can get the values of lambda by t and n lambda. So we will find that 2 pi by t is 36 and minus 2 pi by lambda will be 0.018. If we divide the numbers, we get the following answers to that. So minus lambda will be equal to t multiplied 36 over 0.018. You can put and get the value. So it is n lambda, we have computed the value and we got n. So n lambda is v, speed of the wave is minus 2000 centimeters per second, or it is 20 meters per second. We have converted to meters. Negative sign indicates that the wave traveled from right to left. The negative sign. The wave traveled from, more accurately, it should be left to right, because phase will be negative. That is, phase will be positive if wave is moving in the positive direction. And if it is moving in the negative direction, then it means it will be positive. So, if it is negative sign, it is moving in positive direction. But if it is positive sign, it is moving in negative direction. The rule is plus to the right, minus to the left, positive height and negative depth. So we compare the equation, and amplitude is found to be 3 centimeters or 3 into 10 to the power minus 2 meters. And because according to the equation 2 pi by t is 36, so we get the value of t, that is 2 pi by 36, and from that we get n, because n is 1 over t. Initial phase is given by pi over 4, that is according to the equation, and 1045 is 1. Since 2 pi by lambda is 0.018, so distance between two successive crests, that is, we put the formula for lambda, we put the values, and it is found to be 3.5 meters. Now our next question is a simple harmonic wave train. That is, simple harmonic wave is continuously moving, that is called wave train, is traveling in a gas in positive direction of the x-axis. Again, we are using positive direction of the x-axis. It means that phase should be negative. Its amplitude is 2 centimeters, velocity is given 45 meters per second, frequency is 75 per second. Find out the displacement of the particle of the medium at distance of 135 centimeter from the origin in the direction of the wave at the instant t is equal to 3 seconds. Now, first of all, check the equation. That is equation number 1. And we have taken again a negative sign because wave is moving in the positive direction of x-axis. So y is equal to a sine 2 pi into t by t minus x by lambda. A is amplitude, t is time period, and lambda is wavelength. Here is 2 meters. That is given to us. So amplitude, this one given. And v is 45 meters per second, n is given. So t is 1 over n. This we will calculate, and we will find v over n, velocity over frequency, is length. That is also given, and it is found to be 0.6 meter or 60 centimeters. Put the values of a, t, and 1 and l in equations, and we will find that our equation will become y is equal to 2 sine 2 pi 75t minus x over 60. Y and X are in centimeters to in seconds. To find the displacement at distance of 135 centimeters from origin at the instant t is equal to 3 seconds, we substitute t as 3 and x as 135 centimeters in the above equation. And by putting these values, we get, we get various equations. That is, one is y is 2 sine 2 pi 225 minus 2.5. And similarly, we just wrote the equations 2 sine 450 pi minus 5.5, 4.5 pi. Similarly, the other equations are mentioned. And the last equation, y is equal to minus 2 sine pi by 2 equal to minus 2 cm, centimeters. When we say sine pi by 2 means sine 90. So sine 90 will be 1. So it is minus 2 centimeters. Two particles C and D are executing simple harmonic motion with the same amplitude. So there are two particles and they are executing SHM, but their amplitudes are same. Frequencies nu are also same and also same straight line. The maximum distance between the two particles is, and the initial phase difference between the two will be how much? So we take the general equation A sine 2 pi omega t or A sine 2 pi nt. Then it is y2, second displacement. It is A sine 2 pi nt plus theta. Then we take the difference of the two displacements, y2 minus y1, and we make the necessary calculations. Earlier equations were 1, 2, and 3, and after calculation, the equations are 4, 5, and 6. So from equation 1 and 2 and 3, the equation will become 2a sine theta by 2 cos 2 pi nt plus, that is theta by 2. Like this, we will solve out the equation, and we find that from equation 4, we get the displacement maximum. According to equation y maximum is a root 2. And from equation 5 and 6, 2a sine theta by 2, and that can be written as sine theta by 2 is equal to 1 over root 2. And 1 over root 2 when we speak, sine theta 1 over root 2, theta by 2 must be 45 degrees, and theta if we calculate, it will become 90 degrees or pi by 2 radians. Now, if equation of transverse wave is y is equal to x naught cos 2 pi nt minus x over lambda. This is again a general equation of SHM. So, is y is equal to this much is maximum velocity of particle is twice the wave velocity if lambda is. So, we have to estimate the value of lambda. First of all, we will write the equation of displacement x naught cos 2 pi nt minus x by lambda. We take the derivative, or we can directly find this value. It is a multiple of 2 pi 360 degrees, and if we take LCM and simplify the result, we can write the number as y is equal to x naught cos 2 pi by lambda Vt minus x. Lambda can be replaced by Vt. So because V is equal to n lambda. So we take the derivative of the function dy by dt with respect to time maximum, and we have taken the derivative of the right side also, and we found that the number comes x naught into 2 pi by lambda into nu or 2 nu, given that lambda is equal to x, that is pi x naught.